Okay, I've got my Bunsen burner, my source of thermal energy. I'm going to place it beneath the beaker. The thermal energy from the Bunsen burner is going to be transferred to the water, increasing its store of internal energy. The kinetic energy of the particles is obviously going to increase, its temperature is going to rise. We're going to keep increasing its temperature until it starts to boil. Once it starts to boil, I'm also going to continue to supply thermal energy to the water. What do we think is going to happen to the temperature of the water as it boils? Do we think the temperature is going to stay at 100 degrees? Do we think the temperature is going to continue to rise as I continue to add thermal energy? Or do we think the temperature is actually going to decrease? Okay, I've set the data logger to record the temperature over time. Let's set it to a roaring flame. And very carefully, start heating the water. So we should be able to see the temperature is starting to increase. What do we think is going to happen to its temperature as it boils? Okay, we can see here I'm plotting a graph of temperature against time. The temperature is currently 76 degrees. Apart from a couple of small anomalies in there, we can see there is approximately a straight line, approximately a proportional relationship between temperature and time. And we can see over here the water isn't yet boiling, but you can see it's starting to get quite hot. Let's continue watching this graph. Let's see what happens to the temperature as it reaches boiling point. Okay, the water is starting to boil, as you can see. We've got our graph of temperature against time. And you can see the graph has started to plateau, started to level off. The temperature is not increasing beyond 97 degrees. Now, obviously, that should be 100 degrees. We can have a little think perhaps about the reasons why that might not be reading 100 degrees. But hopefully you can see the temperature is not rising, it's staying constant.